How old is the universe? Well, that depends on how big you think it is. On Earth, dimensions and distances are hardly a challenge. But how to scope out the distance to, say, the moon?
It's possible to measure distances to places you can never, ever hope to get to.
To figure the span between the planets, Mercury, for example, you can use radar. The world's largest radio telescope at Arecibo, Puerto Rico, does exactly this. Just like an air traffic controller, you could send out a train of high-power energy pulses and time their return. You know your signal is traveling at light speed. Take half the interval between pulse and echo, divide by the speed of light, and congratulations, you've got yourself a valid distance datum. So far, so good. But what if the object is so far away that it would take years for a radar signal to get there, assuming you could even build one powerful enough? Answer: the parallax method. Hold your finger at arm's length in front of your nose. Close one eye, and look at the most distant thing you can see out your window. Now, switch eyes. Back and forth. Imagine your eyes are two telescopes, and the distance seen is a field of background stars. Your finger is a nearby star. To measure the distance to that star, all you need is the span between your eyes and the angular change in the apparent position of your finger relative to the background. There's probably an easier way to figure the distance to your finger, but you get the idea. Astronomers can observe a nearby star against the background of more distant stars, and then repeat the process 6 months later, when old Earth has sped nearly 470 million kilometers round to the other side of its orbit.
And so that little shift is like the way your finger is shifting against the background. Because it's like we had two big eyes in the sky, one blink in December and one blink in June.
The parallax trick works well for nearby stars. About 100,000 have been roughly measured, but its effectiveness drops quickly as you look farther out. To begin figuring distances in really deep space, you'd be in good shape if you could count on some kind of standard object to be there, far away, glowing with a well-calibrated brightness. Since you know that light power falls off as the square distance from its source, well, anyway, now you know it. If you see one of these standard candles in a faraway galaxy, quick as a wink, you can derive the distance. Such standard candles exist in the cosmos. One example, the Cepheid variables. These stars pulse in and out like a beating heart.
And it turns out that there's a very tight, well-known relationship between how fast they're pulsing in and out and how bright they are. So if we see a star in another galaxy that's getting brighter and dimmer in this way, and it's got the right color, and we say, that's a Cepheid. I know how bright it is, so then you get the distance to that galaxy.
But what if the galaxy is so far away that you can't see individual stars? Welcome to the redshift zone. Here's the deal. As an object moves away from you, its light looks more and more red in color, because the wavelength of its light is being stretched out by the expansion of space itself, and the amount of this shift to red is proportional to how fast it is moving away. The further away from you a galaxy lies, the more quickly it's moving away. Factor this in with the amount of redshift you measure, and you can figure the distance. Now, the magic number that relates the recession speed to the distance was the subject of decades of raging debate. It's called the Hubble constant, in honor of Edwin Hubble, who first revealed the expansion of the universe. Funnily enough, observers using the space telescope named after Hubble have recently settled the argument by getting reliable distance measurements to 24 galaxies. The result? The universe is expanding at the rate of 23 kilometers per second per million light years away from you. Run the movie backwards to find out when everything converges and the age of the universe is revealed. 13 billion years.